Welcome everyone. In this video we're going to be configuring a TensorFlow model server to serve a custom model. And once we have that set up, we're going to, on another system, we're going to set up a client so we can communicate with the model server over the network. And we'll be conducting an image recognition test to test the model server to see if it's working properly. First off, we'll need a operational installation of the model server. Previous video steps through that process. So if you need to go back to set up the model server, then go ahead and do it. And let's see, I'll put the link in the description on this video. So with that said, let's go ahead and get started. Okay, first we're going to set up the server side of the terminal right here. And we're going to create the location where the models are going to be stored that we're going to be serving. So let me do a print working directory. And I've created a folder called New Squirrels under my user's home directory. So once you do that, let me do an ls. You'll need to create another one folder in there called 1, the number 1. I don't know if you can see it very well. It's right there. And then from there, we'll go into the 1 directory or folder. Just do an ls. This is the PB file extension, and we have our variables and asset folders. All of this is created when the model is trained and saved, and that'll all go into this location the model server will access. So once we've done that, we'll go to root, do an ls, and in our previous video, we created a folder called models. So let's go into that. LS, and that's the folder that we tested the model server on in the previous video. This is the test data that's provided by the installation. It's part of the installation files. We need to make another folder, and we're going to call that, I guess, call it the same thing as the model, saved model. Okay, and let's do a enter. ls, there it is. All right, we're good. All right, the next step is to make sure, or to start up our model server. So let's go ahead and make sure we're up and running. Let me do a clear. Okay, and we need to make sure Docker's running because the model server's stored in a container, a Docker container. So let's see, system control, let's do a status. Docker, we are not running, so let's go ahead and start that up. Docker or start Docker, enter, and it should start up. So we'll do another status, and we see that it's running now, active, running. So we're good there. All right, so now that we have Docker running, let's go ahead and start up our model server. So we will do a Docker run -t-rm -p. This will be the port to for the RESTful API that we'll be listening on. So that would be 8501:8501, and then we'll do a -v and a quote. And now we're going to enter the path that are for the location that our model's actually saved. So this, for me, it will be home demo and New Squirrels. And then we'll do a colon, and we'll enter the location of the folder we created under models. I believe it's called saved model. So let's go ahead and put that in. So models, saved model, and we will do an end quote space -e, and this will be the model name equals, and our model name is actually saved model. So then we'll do entry will be TensorFlow /serving, and we'll do the ampersand so it runs in the background when it starts up. All right, so let's go ahead and space and our last, see what happens. So hit enter, and it looks like we've successfully started the model server, and it's reading from this directory, or from this folder, the 1, which is where we have our model saved. So it's reading the correct model. So let's go ahead and hit enter here so we get back to the prompt. Let's do a clear, enter, and now that the model server is running and it's successfully ready to serve our custom model, let's open firewall, open up 8501 in the firewall. So this will be firewall command -- add -port equals 8501/TCP, and we'll do a dash dash to make it perm, or a dash dash perm to make it perm, and hit enter. So in my case, it's already enabled. So I've done this before on this machine. When you do it, if it's not open yet, you'll just get the success once the port's successfully opened. So that's it for the server side. So let's go ahead and move over to the client side. All right. So first off, I'm going to do this in a conda virtual environment. So let me activate my environment. On to activate, and I've named my environment TensorFlow. And hit enter, and you can see here by the TensorFlow in parentheses that I'm in my environment now. And I've created a folder called TF Client underneath the TensorFlow home directory. That would be my home directory for my virtual environment. So TF Client's located under that. Let's do an ls. I have test images here for testing after we set up our client. So let me do an ls. Test images. We have 4 images that we're going to test with our model. So let's go ahead and do a clear. Let's do a VI, and we'll name this client.py. Enter. Okay, so let's go ahead and create our client. We have some imports that we need to do. If you're in a virtual environment, you'll use pip to install these packages. And let's see. So let's do an import. Oops. Import TensorFlow as TF, enter. Import from TensorFlow.keras.pre-processing. We'll import image, enter, and we'll import NumPy as NP, enter, JSON, import JSON, and import requests, enter. And let's move down a couple lines. So we'll do a test image equals image.loadImage, MG. Then we'll do a parenthesis. We'll do a single quote, and this will be the path to the image that we're going to use for testing. So this will be, in my case, demo TensorFlow, and then I believe it's TF model or TF client. And then we have test images, and I believe we're doing, let's do flying. Look over here, and let's do an ls on the test image folder. So I have 4 images, and one of them is flying. So we're going to use that one in our test here. This is the server side. I have images on both systems, so it's easier just to look here than to get out of this and look and go back into it. So let's see. So this will be flying. .jpeg. Then the end quote, comma, target size equals 256, 256, 3, and this will be a double closed parenthesis, and enter. All right, the next entry will be test image again, equals image dot img to array, and then we will have a test image. So this will be accessing or reading from the image that we're using for testing. So let's see, enter. Next entry will be test image equals tf dot expand dims, and this will be test image, and axis equals 0, and we'll have a closed parenthesis, and then enter. Do another test image. So test image equals will be test image dot numpy dot to list. and then we'll have open and close parenthesis. All right, so our next step is to hit enter here. Now let's move down a couple lines and we will put in our output. So we'll insert. In this entry, we're going to be communicating with the server, with the model server on the other machine. So output equals single quote 2.168.1.13 is the IP for the other system, and 85.01 is the port we're going to be accessing. /models is going to point to the saved model the saved model folder that we created under the models folder earlier. So saved model, and then we will do a colon and a predict, and then the closed single quote. And we'll go to the next line, and we're going to enter JSON data equals, and then the brace or whatever this is called, and we'll hit enter. We'll do a quote, do an instances, closed quote, colon, space, test image, enter, and then we'll do the closed brace. All right, so from there, we'll put in a response, and this is requesting a response from the server. All right, response equals requests dot post to see output, comma, JSON equals JSON data, and then we'll do a closed quote, and I'm going to print response just to see what happens. And we're going to close this and run it, see if we get any errors. Make sure we've done this correctly so far, so right quit, and then we'll do a Python client. And response 200, so we're good. That means that we successfully communicated with the model server. All right, let's go back into our client, do an O for open, next line, and we'll do a prediction equals tf.arg, argmax, response.json, open and close parenthesis, and then we'll do a bracket, we'll do a single quote, predictions, closed quote, closed single quote, and then the closed brace, closed brace, and then we'll have another open brace, 0, closed brace, and then a closed parenthesis. And we will move to the next line, print prediction dot numpy, double parenthesis, open close parenthesis, and then another close parenthesis. All right, so let's hit enter, and let's go ahead and hit escape, right quit, see what we have. And we have a response as 1, so that looks correct. This is the flying squirrel, so that is correct. All right, so let's open labels, or label equals. Let's see, chipmunk. Oops. Chipmunk. Flying. Fox. That's a type of squirrel, not a fox. Gray. Ground. And red. Closed parenthesis. So these are the labels for each of the test images we're using, or these are the labels for the categories that we're using in this model. So let's see, we'll hit enter here. And let me fix this, geez. All right, escape open, enter. We'll do a label 2 equals np.array label, closed parenthesis, do a x equals label 2, and we'll do a bracket, prediction, closed bracket, and the closed parenthesis. All right, we'll hit enter, and we'll do a print x. Let's do an escape, right quit, enter, and now let's go ahead and run the client to see what we get back. All right, one, flying squirrel, but identified it. All right, I think that's it. I hope this is helpful and useful to somebody. So like always, please like my videos if they're helpful to you or useful, and subscribe to my channel. I would appreciate it, and I will see you next time.